Okay, so this will be our last video on this type of right triangle trigonometry. This sort of wrap up what we had for the previous videos. If you have not seen those, don't know what right triangle trigonometry is, this is not the right video to start with. But as a reminder, for right triangle trigonometry, we had this mnemonic device, so, ka, toa, and that let us know that if I have a right triangle with some one of the acute angles, the sides labeled opposite leg, adjacent leg, and hypotenuse, then the sine of that angle would be the opposite over the hypotenuse. The cosine of that angle would be the adjacent over the hypotenuse, and the tangent of that angle would be the opposite over the adjacent. So let's dive right into some of these problems and see how they work. So you are standing 15 feet away from a flagpole. If you look up from the ground with a 65-degree angle of elevation, how tall is the flagpole? So I mean, I can draw a flagpole. I can draw a person. Isn't this a lovely person? I can even sort of represent the person looking up, which actually this isn't the correct diagram for what we have. But the question is, how do I figure out how tall this is? So we should have some idea already, but let me address a couple of sort of foundational skills first. The first one is, in general, just right triangle trigonometry word problems. So the idea is, for this, I want to try to make a right triangle out of the problem. In this example, I don't have a right triangle yet. I have a flagpole, I have a person who's like shooting beams out of his or her eyes, I have a variable, but I don't have the triangle yet. And the thing that makes it trigonometry, let me change color. The thing that makes it trigonometry is, in this case, I want to somehow relate sides with acute angles. So every right triangle has a right angle, but if I'm dealing with the sides and one of the acute angles, now I'm going to go ahead and use trigonometry. Okay, a couple of important words though. So angle of elevation, angle of depression. These are just measures of the angle above for elevation or below for depression. I'll say the horizontal. Now, there's a good reason we use horizontal. So if we overly simplify the world, we could say, okay, ground is going to be flat, horizontal. And if I have something going on, like I've built a building or have a tree, I can maybe simplify this to being a right angle. Here's where the angle of elevation comes into play. The angle of elevation would be this angle right here, the one off of the horizontal. Only difference for angle of depression is if I had something, and I could come up with angle of depression for things like airplane problems, hot air balloon problems. So instead of having something where it's looking or traveling up, if I wanted to look or travel down, that would be the angle of depression. Now, a common mistake that I see way too often is when people make this diagram, someone's going to try to stick that angle of elevation right here. Or someone's going to try to stick the angle of depression right here. That is wrong. It's always off of the horizontal. So I take my horizontal and have the angle from that. I take my horizontal, I have the angle from that. Do not I'm going to put this in red. Do not use the vertical if I'm dealing with elevation or depression for my angle. So let's get back into that example we just saw, and let's get an answer out of it. So in here, I'm standing 15 feet away from a flagpole. If I look up from the ground with a 65-degree angle of elevation, how tall is the flagpole? Well, I can simplify that down to this shape. I have my flagpole. I have me over here. And I want to find out how tall this flagpole is. Now, if you recall in my original diagram, I have us looking at the flagpole from how we usually look at things, from our eyes, in our head. But there's this interesting word here that says from the ground. And that is important for this problem because I want to measure the whole height from the tippy top to the bitty bottom of this. And so I'm going to actually make sure to measure my angle from the ground. So you could think of that like you get down your hands, like on your stomach, and you're looking up. Silly way to look at a flagpole, but that's how this problem is formulated. Okay, I already want to know how tall it is, so there's my x. I'm going to assume that the flagpole is perpendicular to the ground. Again, not always a great assumption, but ones we will make for our class. I'm 15 feet away from the flagpole. Well, the flagpole is here. I'm here. Here's the 15. And I know that I have a 65-degree angle of elevation. Again, the angle of elevation will always be from the horizontal. So I'll put a 65-degree angle right here. And now I can set up my right triangle and my trig equation. So I notice I have my angle. Here's the hypotenuse. There's the opposite side. There's the adjacent side. So when I try to do so, ka, toa, I look for the one that has the O and the A. That would be toa. I will write tangent of 65 degrees is equal to x over 15. Now I'm going to go to my calculator and just evaluate the tangent of 65 degrees. So now I have like two different functions to use. I am taking the tangent of an angle, so I don't want the inverse tangent. I want the regular tangent. So I'll type in 65 and press tangent. That gives me 2.14451. So 2.14451. I'm going to keep some extra information here and round later on. I have x over 15 over there, and the simplest way, not always the quickest way, but simplest way is just make a proportion, cross multiply, so I'll get x times 1 is x. I guess that should be approximate. And 15 times this, let's go to times 15, is about 32.168. So 32.168. And I'll stick in here that we measured this in feet, so this length will also be in feet. Okay. Here we're trying to kick a football so that it goes from one corner of an American football goalpost to the opposite corner. So if you're thinking about, international football with this and like football, soccer, there you go. We're not dealing with this. Okay, let's just make that disappear. Again, this is the one that I have played in the past, but we're talking about American football. So we're talking about this with a football shape. Okay, so we want to know what angle we should kick it. So basically I need the right triangle. And let's see what we have. So in here, we're told the goalpost is 18.5 feet across. I'll make this 18.5. We're also told it's 20 feet tall. So that means that this is 20. Now, I wasn't specific in my wording, but this is the 20. The 20 does not include that portion right there. And now, I make a right triangle. I want to know what angle I should kick the ball. Well, that's going to be this angle of elevation right here. And just like before, I have I'll mark the sides. So here's my hypotenuse, there's my opposite, there's my adjacent. I have the opposite, I have the adjacent. So when I look at toa, the one with opposite and adjacent is tangent. And I'll write tangent of theta equals opposite over adjacent, 20 over 18.5. Now this is the easier case. I don't need to do a bunch of algebra. I just need to realize to get rid of the tangent, I do inverse tangent. So theta equals the inverse tangent of 20 over 18.5. I go to my calculator. I do 20 divided by 18.5. I need the inverse tangent to get that. See, that's normal tangent. I press second and I see now, okay, that's inverse tangent. And I get 47.231. So it's about 47.231. And the measure on that is degrees. So I should be kicking it at about a 47-degree angle. All right, one more example. So you're building a handicapped accessible ramp. You have used your protractor, because you're super cool and carry a protractor around all the time, to determine how steep the ramp is, 11 degrees. You know that the ramp is 15 meters long. In order to make sure that it satisfies building codes, you need to know how tall the ramp is, but you forgot to measure it while you were at the building site. Calculate how tall the ramp is. So what we have is this. Again, I have a right triangle, and what could happen, and this could truly happen, you may actually be working in a site and say, okay, I built this. I know that I measured this to be 15 meters. I know that I measured this to be 11 degrees because I had my protractor on me. I needed to know this number, but unfortunately, I was too dumb to get it when I got there. You know, some people, you forget things, so you gotta fix your mistake. Well, let's use a little math so you don't need to drive your car all the way over there and waste who knows how long getting there. So in here, I'm going to label these up. So here's my hypotenuse. There's my opposite. There's my adjacent. I have H. I have O. Looking at toa. I know that I have O and H. That's going to be sine. So I will do the sine of 11 degrees is x over 15. I'll go to my calculator and I will type in the sine of 11. Now notice my calculator is still stuck on inverse sine, so I'll press this again. Now I can take the sine. So it's about 19081. So 0.19081. And that will be approximately x over 15. I will set up the proportion, cross multiply. 1 times x is x, and 15 times that is approximately 2.862. And there's my answer. Okay, if you need more help, want to see a few more examples, there will be a link to 4 more worked word problems, a video with that. There will also be a link to a worksheet so you get some practice on your own.